line by being perpendicular. The normal line is the line associated with a curve that's perpendicular to your line of tangent. All right, so yeah, we're used to having our tangent line T. Well, the normal line would then just take would come in and would be, well, just perpendicular to that and 90 degrees to that. Just another line of interest. All right, well, what do you know about perpendicular lines? How are they related as far as their slopes go? Well, perpendicular lines have slopes that are what?
Opposite.
They're opposite. And what else? One's a positive, one's a negative. That's right. There's also another catch. Reciprocals, yes. Opposite reciprocals. So if we have a slope of our tangent line is 2/3, then the slope of the normal line, well, that's just the perpendicular to it. What would be perpendicular to it slope-wise? That would be -3/2. Okay? So it's really just about that easy. So if I wanted to find, tell me how to do this, find the equation of the normal line to the curve y equals cube root of x minus x squared at the point 1, 0. Find the equation of the normal line to a curve. Same thing as finding the equation of the tangent line, it's just that I'm going opposite reciprocal of the tangent line. So even though I'm trying to find the normal line, I still need to know the tangent slope. How do I get the slope of the tangent? Well, that's going to be what? How do I find the slope of the tangent? Derivative, right? Slope of the tangent's the derivative. So what's the derivative here? Well, that's, how do I do the cube root? Cube root is x to the 1/3 power. So the derivative is going to be 1/3 x to the -2/3. So I subtract 1 from 1/3, that'll be -2/3, won't it? Minus then the derivative of that would be 2x. So in particular, I'm interested in the 1, 0, slope at 1, 0. Well, that's just x is 1, isn't it? The x value is 1, so the slope of your tangent's going to be, well, that's nice because it's 1 again. It's 1/3 minus 2, which is -4/3. However, that is not what I'm wanting here on this problem, but I have to find that one. Everybody with me on that so far? That's not right, is it? It's -5/3. 1/3 minus 2 is -5/3. Sorry about that. All right. Yeah, I'm wanting the normal line, so how do I get that? What's the slope then? That's the slope of the tangent. The slope of the normal line would be then this perpendicular slope, right? The opposite reciprocal. So the slope of my normal line is going to be m equals what? Positive, opposite, and reciprocal 3/5. 3/5. So the equation then of the normal line, I've got my y equals mx plus b. I've got my m, and so that would be 3/5 x plus b. Plug in x and y to 1, 0, 0 for y, 1 for x. It looks like negative 3/5 is b. So the normal line will be y equals 3/5 x minus 3/5. Okay? And you could graph it and make sure that, on the curve, it's going to be not tangential there. It's going to come in perpendicularly, so to speak, to the curve. All right. Is that okay? Any problems or concern? Now, the other thing to finish up on this section is this problem right here. Well, let's just mention take this problem here. So we got 1, 2, 3, 4. Where is the tangent line horizontal there? Well, we covered this in different ways here, but I've got two places where the tangent line is horizontal, and that is here, well, I meant to be about 1, and then here at 3, right? X is 1, and X is 3. All right, well, what's special about that, or what, from the calculus perspective, do we know about where the tangent line is horizontal? Well, we're talking derivative. What's special about the derivative then at these horizontals? What's the derivative at the horizontals? Horizontal tangents. Yeah. Another way to look at it, where's the tangent line horizontal, is also basically saying where the derivative is 0. If this is y equals f of x, anyway. Yeah. All right. The reason I mention that is because how would I find then where the tangent line is horizontal for y equals 3x to the 4th minus 8x squared plus 4. Well, again, I could sketch the graph and I could locate those horizontal tangent lines, but since the tangent line is horizontal, the slope is 0, therefore the derivative is 0. Can't I do this with the derivative? Yeah, if I'm looking for those horizontal tangent lines, what I'm going to do is set the derivative equal to 0. So, get my derivative, 12x cubed minus 16x, be the derivative. And since I want tangent lines horizontal, what do I do to my derivative? Set the derivative to 0, right? Yeah, for horizontal tangents, the derivative is 0. So I'm going to set derivative equals 0. And solve accordingly. That would be factor out of 4x maybe. So that'll leave me 3x squared squared minus 4. 4x equals 0. 3x squared minus 4 equals 0. Go ahead and solve this out. So that's 0. So I do have a horizontal at 0. What about this one? Add 4, divide by 3, square root both sides. And this side could be plus or minus. And so yeah, that tells me there, that's not a nice number right there. So even if I did just graph this and tried to look at it, this gives me exact values, whereas if I look at the graph, I'd say, well, it looks square root of 4/3 is a little over 1, so it's probably going to be, matter of fact, let's just look at it. 3x squared, just make sure, 3x to the 4th minus 8x squared plus 4, graph. Yeah, okay, so there you go. You've got these yeah, you can clearly see where they are. It's just that these look like they're pretty close to 1 and -1. However, it's a little bit off of that, you see, is what I'm saying. This way gives us a way to find exactly